Yo, Snoop, what you know about Ethereum Attestation Service?
I don't know a thing past that thing. The knowledge, obviously.
Those were not real Kanye or Snoop Dogg talking about Ethereum Attestation Service, but they were clips generated using a generative AI tool. The generative AI tools right now has become so powerful that they can generate realistic videos, and it kind of becomes difficult to identify what is real and what's not. So this can be solved using Ethereum Attestation Service. And that's what we will learn in this video. So hi everyone, Sahil from QuickNode here. And in this video, we will learn about Ethereum Attestation Service or EAS. And we will also see how to use it. But hold on, if you haven't subscribed to the channel yet, please consider clicking that subscribe button. It works as an attestation for us that you folks are liking our videos. And now let's jump into it. There's a vast pool of information online, but verifying what's authentic and what's not can be a challenge. With Ethereum's vision of decentralizing everything, came various protocols or applications that attest to a certain activity or information on chain. For example, Lens protocol attests to your social activities on chain, and Gitcoin Passport attests to your contributions to various projects on chain, and a lot more applications like this. But all of these are fragmented pieces of a puzzle and has their own mechanisms to make these attestations. So it can become very complex for someone who wants to work with these protocols or to see how these attestations works. So that's what EAS solves. It acts as a base layer for all the attestations. EAS or Ethereum Attestation Service provides an open source infrastructure that anyone can use to attest anything, either on chain or off chain. EAS architecture is very simple. It works on two main smart contracts, schema registry.sol and EAS.sol. Schema registry.sol is used to register a new schema for attestations. A schema is nothing but a data structure for attestations. For example, if you want to attest content pieces using EAS, the schema for it can have content hash, which is nothing but the hashed format of the content name, and the data structure for it can be byte 32. And the other one can be URLs of that particular content piece, and it can be a string. The another contract, EAS.sol, is used to register any attestations which can be made on a pre-registered schema. It's as simple as that. You register a schema and then you make attestations onto that schema. Another additional contract is resolver contract, which can be used to perform further complex tasks whenever a attestation is made. For example, mint a NFT whenever a attestation is made, or send tokens, or even execute a smart contract function whenever a particular attestation is made. So now that we know what EAS is and how it works, let's see how an attestation can actually be made using EAS. So first of all, to work with EAS, we will need to install the EAS SDK. This is the TypeScript and JavaScript SDK. So we will install the SDK along with .n to work with environment variables. All right, so once it's installed, let's open the directory in a code editor. Let me increase the size. All right, the first file will be the environment file. In the environment file, we will need few things, two things to be precise. One is the RPC endpoint that we will be using QuickNode, so QuickNode endpoint. And the other would be your wallet private key. Save it. Now let's create a new file. Let's name it schema.js. This will be our file for making schemas. So this is how the code looks like. We are importing few things over here. First, we are importing the SDK. Second, we are importing the ethers so that we can talk to the blockchain. Then we are importing .env config so that we can use the environment variables which we just created in the .env file. And then we are storing the address of schema registry.sol on Sepolia chain in a variable, then invoking that smart contract, and then creating a function for registering the schema. Over there, we are invoking the provider, which will be our QuickNode provider, the signer, which will be our wallet, which will be generated using our private key. And this will be our actual schema. So in this example, what we will do is we will attest a particular blog post. So let's look for a blog post. So we will attest this blog post. We will attest the link to the author's name as well as the date it was posted. So we will need three information. So we will need the link, we will need the name or the author of the blog post, we will need the date when it was posted. So everything can be a string. So let's start. The first thing, let's write author name. Second thing can be URL of content. Third thing can be again string and date of publication. Okay, this will be our schema, and that's it. That's how a schema looks like. The first thing will be the type of the information you want to attest, the data type of the information, and the second thing would be the key. For example, author name over here, URL of the content over here, date of publication over here. And this is just an example. You can make any kinds of attestation. You can use any kinds of data type. For example, if it's a graduation certificate from a university, it can be the name of the student, which can again be a string. Another thing can be percentages or marks that particular student has obtained, which can be an integer. Then another thing can be date of diploma, which again can be a string. So that's how a schema looks like. We have declared it and stored it in a variable called schema. And then we are just saying that if it's revocable or not. Over here, we are saying it is. And then we are constructing a transaction body over here, where we are sending the schema as well as the revocable variables, which contains our information about the schema for attestation. And then we are just sending the transaction and logging the transaction body in console. So we will need to fill this environment variable. First one is our QuickNode endpoint. It can be any endpoint, but has to be on the Sepolia network because this example is on Sepolia. So let's get a Sepolia HTTPS endpoint over here. And let's copy the URL, paste it here. Let's go back. Now to get some funds, you can go to faucet.quicknode.com and then copy your address of whatever wallet you want to use to interact with the smart contracts. I already have some funds in the wallet, but just to show you all how to get funds from the QuickNode faucet, I'm showing you this process. So I'll click on Ethereum, select Sepolia because we want to interact with a Sepolia smart contract, and then click on continue. Because I already have funds, I won't be doing that. But if you want some funds, you can just go to faucet.quicknode.com and get some testnet funds. And the next thing would be the private key. I won't be showing my private key because of obvious security reasons, and you shouldn't as well. You should never share your private key in a public forum or whenever you are sharing your screen, or you shouldn't even use your private key of the main wallet where you store or hold a lot or all of your funds. Now let's register our schema. So let's run the file. So now what it's doing is sending a transaction to the schema registry.sol smart contract deployed on Sepolia. And as you can see, once the transaction is sent, we will receive a transaction body. So let's copy the hash, go back and open it in Etherscan or look it up in Etherscan, Sepolia, then paste the hash over here. As you can see, the transaction is still processing. It's not confirmed yet. So once the transaction is confirmed, you can go to logs and see that a registered event was emitted, which means that our schema was registered on the schema registry.sol smart contract. And if you want to track these registered events, so whenever a new schema is registered, you will get a notification. You can do so using quick alerts. You can check out how quick alerts work and how you can set up your own quick alerts in the top right corner in the information button. Now, this information, which is the unique identifier of our schema, is important to us. Let's look at it in EAS scan. Let's switch to Sepolia again over here. Paste the unique identifier or UID over here, and you will see that this is the schema, is what we actually registered. So now let's make attestations to the schema. Let's go back to our code editor, create a new file to make attestations, attest.js. In this file, we are also importing a bunch of stuff. We are importing the EAS SDK. In that, we are importing the EAS as well as the schema encoder module. Then we are importing ethers.n to work with the environment variable. And in this case, we want to connect with the EAS.sol smart contract. So that's what we are doing over here on this line, and creating a new function attest. And then to talk to blockchain, we are invoking the provider using our QuickNode endpoint URL and invoking our signer, which will help us sign the transactions, invoking the EAS smart contract, and then connecting the EAS smart contract with signer. And over here in schema encoder will go our actual schema, which we created. So let's copy it from here. Replace this part with our actual schema. And in encoded data, we will send the values to our schema, whatever we want to attest. So the first one would be the name. So the name is this, and the second one will be the URL of content. So it will be this. Third value will be date of publication. So it can be this. And then we will have to set up the value. But before that, let's set up the type. For every value, the type is string. All right. Now let's get the values from the actual blog post. Caution. So this will be the name. Let's get the URL. And then the value or the date of publication is December 13, 2023. Let's get that. Then save it. And now we will need the schema ID or the schema UID, unique identifier, which we saw over here. And let's copy this, replace this with the actual unique identifier. And then the transaction body is over here, where we are sending the schema unique identifier. In data, we are sending the recipient address. Recipient address can be anyone who we want to be the recipient of the attestation. It can be anyone whom you want to attest to. For example, in the same university scenario, if a university wants to attest or give diplomas, the recipient address can be address of any student. In this case, I will just write my ENS, which is linked to another address. And then the expiration date, it is 0 over here, which means that the attestation never expires. Revocable true, because the schema was revocable true as well. And then the actual data, which we encoded over here. And then we are just ending the transaction and logging the attestation ID in console. So everything looks set up. Let's save it again. And now send the attestation to EAS.sol. So let's do that. Now it's sending the transaction to EAS.sol to make attestation. Alright, once the transaction is sent and attestation is made, we will get the unique identifier of the attestation. Let's copy this and look it up in EAS scan. Okay, so as you can see, our attestation looks like this. This was our author name. This was the URL of the content piece and the date of publication. So this is how you can create your own schema and attest to that schema. This was a very simple example of attesting the author's name, the URL, and the date of publication for a content piece. But you can create your own complex custom schemas to attest whatever you would like. And once a schema is created, you or even anyone else can use it to make attestations. They just need the unique identifier of a particular schema. That's the power of EAS. It's very simple yet very powerful, using which anyone can make any kinds of attestations. So if you learned anything from this video, make sure to hit the like button, subscribe to the QuickNode YouTube channel, and I'll see you in the next one. Bye bye.